Hello friends, welcome to e-lecture series of ICI. In this section, we are going to discuss CPT Section D Quantitative Aptitude Chapter 11 Measures of Dispersion Part 1. Myself, Dr. N.V. Ravi, I am mentor for this session. In this section, we are going to discuss the importance of measures of dispersion in real life and examination for subjects. Now coming to the topic measures of dispersion in the statistics, which is very important for finding the data which varies how much from one observation to another observation. Whereas in the case of measures of central tendency, with the help of data, we can find the identity of one observation, that is called the whether mean, median, mode, geometric mean or harmonic mean. Whereas in the data is concerned, we can find out how it varies or how it has been spread over. That is the idea behind the finding of measures of dispersion. Now, with the help of measures of dispersion, we can find out the data, how it has been spread over it, whether it is scattered or symmetric, we can find it. Now, coming to the point, measures of dispersion broadly classified into: one is the absolute measure of dispersion, second one is relative measures of dispersion. Then, dispersion for a given set of observation may be defined as amount of deviation of the observation, usually from an appropriate measures of central tendency. Measures of dispersion is classified into two ways. One is the absolute measure of dispersion. Then second one is relative measurement. Here the spelling is missed. Absolute measures of dispersion. And whereas absolute measures of dispersion classified into range, quartile deviation, mean deviation, and standard deviation. Whereas relative measures of dispersion is coefficient of range, coefficient of mean deviation, coefficient of variation, coefficient of quartile deviation. These are the important aspects of measures of dispersion. One is absolute, these are absolute, and this is the relative measures of dispersion. And now we are comparing to the distinct point between absolute and relative measures. Absolute measures and are depend on the unit of the variable under the consideration, whereas the relative measures of dispersion are unit free. This is the unit free and this is not unit free, and where they are the not unit free. These are the important items. For comparing two or more distribution, relative measures and not possible measures of dispersion are considered. Compared to absolute measures of dispersion, relative measures of dispersion are difficult to compute and comprehend. Now, coming to the measures of dispersion one by one. Now, in this, we are going to discuss absolute measures of dispersion as well as relative measures of dispersion of each character. Now the important one is range is one measures of dispersion. Now in this range, we are going to discuss the definition. For a given set of observations, range may be defined as the difference between the largest and smallest of observations. Thus, if L and S denote the largest and smallest observations respectively, then we have range is defined as largest and smallest. Generally, range is widely used in the forecasting and weather situations. In a day, suppose particular day, the range between the highest and the lowest temperatures, if you want, the range between highest range is applied that scenario. Now, this is the case of absolute measure of dispersion. Now coming to the point related to the quotient of range. Quotient of range is L minus S by L plus S into 100. For a grouped frequency distribution, range is defined as the difference between the two extreme class boundaries. The corresponding relative measures of dispersion is given by the ratio of the difference between the two extreme class boundaries to the total of these class boundaries, expressed as the percentage. We may note the following important results connection with the range. Suppose we may note important note related to range. Y equal to a plus bx is expressed. There is a linear relationship between the y and x. If we know the range of x, how we can find the range of y? That means here the property related to range remains unaffected due to change of origin, but affected in the same ratio due to change in scale. We called as this is the origin, this is the scale, and range remains unaffected due to change of origin. That means if you add or subtract some element, the range doesn't affect. But whereas in the case of scale, it is affected by its ratio. Then range y may be defined as range y may be defined as modulus of b times range of x. This is the important property related to range. Students, friends, let's come into the point one by one. Range, in the case of absolute measure of dispersion, range is a one kind of measures of dispersion. Range for a data, if you are the largest value, difference between the largest and smallest value is called the range, whereas the quotient of range is the largest minus smallest by largest plus smallest into 100. And suppose the property related to range remains unaffected due to a change of origin but affected in the same ratio due to a change in scale. That is, for any two constants a and b, two variables x and y are related to y equal to a plus bx, then range of y can be defined by given by range of y equal to modulus of b times range of x. This is the important for the examination point of view. Now, coming to the illustrations related to the range, let us go with problem 1. Following are the wages of 8 workers expressed in rupees. They are 82, 96, 52, 75, 70, 65, 50 and 70 rupees. Find the range and also its coefficient of range. Now, already according to definition of range, now we can find the range as follows. First, the largest, we have to identify the largest number in this. Largest number is rupees 96 and smallest number is rupees 50. And thus the range is rupees 96 minus rupees 50, that is rupees 46 is the range. Quotient of range is largest minus smallest by largest plus smallest into 100, which is equal to 96 minus 50 by 96 plus 50 into 100, which is equal to 31.51%, whereas this is the quotient of range for this data. Now coming to the illustration number 2, what is the range and its quotient of range for the following distribution of weights? Weights in kgs 50 to 54, 55 to 59, 60 to 64, 65 to 69, 70 to 74. And respective number of students are 12, 18, 23, 10 and 3. Now this is the case of the grouped data. Now let us look at the data. This is the case of inclusive class interval case. Now, whereas this is the lower boundaries and this is upper boundaries, it can be reduced by 0.5 and it can be increased by 0.5. It can be written as follows. This weight in kgs. This is 49.5 minus 49.5 to 54.5, 54.5 to 59.5, 59.5 to 64.5, 64.5 to 69.5, 69.5 to 74.5. Like this way, we have to write the data, and number of students as it is we have to write. That is 12, 18, 23, 10 and 3. Whereas for finding the range in the case of grouped frequency distribution, here the lowest boundary is 49.5 kgs. The highest boundary is 74.5 kgs. So range can be written as 74.5 minus 49.5 kgs, which is 25 kgs. There is a range between the smallest and the highest value. And coefficient of range equal to 74.50 minus 49.50 whole divided by 74.50 plus 49.50 into 100, which is equal to 25 by 124 into 100, 124 into 100, which is equal to 20.16% in the range of the weight in kgs. Now coming to the illustration number 3. If the relationship between x and y is given by 2x plus 3y equal to 10, 2x plus 3y equal to 10, and the range of x is rupees 15, what would be the range of y? Now let us see the data. Here 2x plus 3y equal to 10 and 3y equal to 10 minus 2x implies y equal to 10 by 3 minus 2 by 3x. Already we are aware of that earlier we have discussed range is unaffected by origin, whereas it is affected by the scale. That means y equal to a plus bx is the data. It is called origin and scale. A is called origin and scale. So the range of x is known, range of y can be b times range of x. Using that property here, now range of y we want to find out. This is the modulus of minus of 2 by 3 into range of x is given in this Question is 15, which is 2 by 3 modulus into 15. 3 5s are, so rupees 10 is the quotient of range for this state. Now coming to the second measures of dispersion, which is mean deviation. Since range is based on only two observations, it is not regarded as an ideal measure of dispersion. Next, further, a better measure of dispersion is provided by mean deviation, which, unlike range, is based on all the observations. For a given set of observations, mean deviation is defined as the arithmetic mean of the absolute deviations of the observations from an appropriate measure of central tendency. Hence, if a variable x assumes n values, x1, x2, etc., xn observations, then mean deviation of x about an average is given by, that is, md of x, mean deviation of x can be based on the average 1 by n of summation of 1 by n of summation of absolute values of xi minus a. A is the here average. For a grouped frequency distribution, median can be defined as 1 by nf summation of xi minus a into respective frequencies, that is I, where we can say that n equal to, this is capital N equal to summation of fi. In most cases, we take a mean or median, or accordingly we get mean deviation about mean or mean deviation about median also. Now students, here we have find the mean deviation on the basis of the set of observations mean. In the case of median also, with the help of median also we can find the mean deviation also, and mean deviation from median is 1 by n of summation of xi minus median, and this is the in the case of median, whereas in the case of median for frequency data also, simply in the case of mean we replace the value median, and coefficient of mean deviation can be mean deviation about mean, mean deviation about mean, that is x bar or a, and by its respective average into 100, and this is from mean. In the case of median also it can be found. Coefficient of mean deviation from median is mean deviation from median by median, respective median, into 100. Mean deviation takes a minimum values when the deviations are taken from the median. Also, mean deviation remains unchanged due to change of origin, but changes in the same ratio due to change of scale y equal to a plus bx. Suppose the data y equal to bx, we have discussed in the case of range also, mean is or unaffected by its scale, origin and its scale. but it is affected by, in the case of y equal to modulus b times of range of x. Whereas in the case of median also, mean deviation from mean deviation also, y it is unaffected by origin, but it is affected by scale modulus b of b times its md of x, mean deviation of x. We have to remember this is applicable for range formula as well as the mean deviation as well as the quartile deviation, standard deviation. Students, remember it is the very important property in related to measures of dispersion, whereas range, mean deviation, quartile deviation, standard deviation are affected in the scale only, but it is not affected in the case of origin. What is the mean deviation about mean for the following numbers? 5, 8, 10, 10, 12, 9. Now we have to find out the mean deviation for this data with the help of using the arithmetic mean. Now first we have to find the mean, the solution as follows. Mean equal to 5 plus 8 plus 10 plus 10 plus 12 plus 9. Here the observations are 6, so which is as follows. 5 plus 8 plus 10 plus 10 plus 12 plus 9, which is equal to 54. 54 by 6, which is 9. Now the simple solution as follows. Mean deviation from mean we have to find. It is the sum of the absolute deviations by the number of observations. It is the sum of the absolute deviations from the mean, and we have to define as summation of absolute deviations of xi minus x bar by n is 6 observations. So this is as follows. Modulus of 5 minus 9 plus modulus of 8 minus 9 plus modulus of 10 minus 9 plus modulus of 10 minus 9 plus modulus of 12 minus 9 plus modulus of 9 minus 9 by 6 observations. That is 4 plus 1 plus 1 plus 1 plus 3 plus 0 by 6, and this is 4 plus 1 5, 6, 7, 10 by 6, and which is 1.67 is the mean deviation about mean. It is the mean deviation about mean. Coming to the illustration number 5, find the mean deviation about median and also the corresponding quotient of for the following profits in rupees thousands for a firm during a week: 82, 56, 75, 70, 52 and 80 and 68 thousands. Now we have to find the mean deviation for this data with the help of median. You have already known the mean deviation can be found with the help of median also. Now median can be find out for this data as follows. You know, the first data can be arranged in increasing order: 52, 52, 56, 68, 70, 75, 80 and 82. Let us look at the number of observations of this data. 1, 2, 3, 4, 5, 6, 7. Here the number of observations are odd number of observations, 7 observations. So 7 plus 1 by tooth item is that is 8 by 2 fourth item is the median. So fourth item is, let us look at 1, 2, 3, 4. The 70 is the median for this data. That means median profit is the 70 into thousands, 70,000. For this data, median is 70. So these are all mentioned in terms of thousands. So rupees 70,000 is the profit for this data. Is the median profits for this data. Now coming to the computation of mean deviation about median. Now for the sake of simplicity, we are not using any thousands here. The mean deviation about median can be computed as follows. The mean deviation about median as follows. This is like summation of xi, absolute value xi minus median by number of observations is 7 here, so n. Now I am simply writing as follows. For this data, median is 70, absolute values of 52 minus 70 plus absolute value of 56 minus 70 plus 68 minus 70 plus 70 minus 70 plus 75 minus 70 plus 80 minus 70 plus 82 minus 70. These are all values divided by 7 observations, and this is absolute 52 minus 70, 18 plus 14 plus 2 plus 0 plus 5 plus 10 plus 12, which is these are all divided by 7, and if you sum up this all these observations, which is equal to 61 and 61 by 7, and these are all in thousands, so rupees 61,000 by 7, which is equal to rupees 8714.28 is the mean deviation from median for this data. Now coming to the illustration number 6, compute the mean deviation about mean for the following data. This is a group of data x 1, 3, 5, 7 and respective frequencies are 5, 8, 9, 2, 1. Also find the coefficient of mean deviation about the mean. This data is a group data. Now first we have to find the mean value before finding the mean deviation. Let us look at the data. This is a grouped frequency distribution. You know, already you are aware of that the mean deviation, mean formula, x bar equal to summation of fx by summation of f. Summation of fx is the sum of each frequency is multiplied respective observation and by number of observation. This is the mean for the grouped frequency distribution. Now coming to the case here, also similar, x bar equal to 5 into 1 plus 3 into 8 plus 3 into 8 plus 9 into 5 plus 7 into 2 plus 9 into 1 by the sum of the frequencies is 5 plus 8 plus 9 plus 2 plus 1. Here this is 5 plus 24 plus 9 into 5, this is 45 plus 14 plus 14 plus 9 divided by 25. This is the whole values after dividing this 3.88 is the mean for this data. For this data frequency distribution, mean we have found, that is 3.88. Now we have to compute the mean deviation from mean in the next slide. Already we know this formula. Mean deviation from mean is based on the frequency distribution, that is summation of f into x minus x bar by capital N. Just remember this formula. In the case of mean deviation from mean for the grouped frequency distribution, each frequency observation is multiplied with respect to x value minus x bar modulus of that absolute value by sum of the observations, that is n. Now coming to the solution, let us look at this can be computed. The mean deviation in the mean as follows. One is the data is x, second one is f frequency, and next one is absolute value of x minus x bar and respective frequency into x minus x bar. Now look at 1, 3, 5, 7, 9. Now in this column we are going to calculate total. The frequencies are 5, 8, 9, 2, 1. The sum of these frequencies is 25. Now we already computed in the last slide, x bar value is 3.88. Now these each value 1 minus 3.88, 3 minus 8.88, 5 minus 3.88, 7 minus 3.88, 9 minus 3.8, all the absolute values, only positive values we are considering here. That is 1 minus 3.88 is 2.88, next 3 minus 3.88 0.88, next 5 minus 3.88 is 1.12, and 7 minus 3.88 3.12, and 9 minus 3.88 is 5.12, and respective frequencies, this value multiplied by these absolute values, that 14.40, 7.04, and 10.08, and 6.24, 5.12, and sum of all these values equal to 42.88, and the mean deviation from mean is computed as follows: 1 by n of summation of f into x minus x bar. Here observations are 25, and after this f into summation of f into x minus x bar value is 42.88, this divided by this 25, 1.72 is the mean deviation from mean for this data. Now coming to the illustration number 7, if x and y are related, 4x plus 3y equal to 0, and mean deviation of x is 5.40, what is the mean deviation of y? Already we have discussed the properties of mean deviation. Mean deviation is affected by scale. Suppose y equal to a plus by x, this is called origin and b is called scale. A is called origin and b is called. When we know the mean deviation of x, the mean deviation of y can be modulus of b into mean deviation of x. This is the simple property we have been already discussed in the earlier slides. Now, coming to the point related to 4x plus 3y plus 11 equal to 0, which is the linear equation already given. Now we have to express this equation in terms of y. 3y equal to minus 4x minus 11, and y equal to simply minus 11 by 3 minus plus of minus 4 by 3 brackets and into x. Now we have to find out the mean deviation of y. Based on the earlier discussion, like now mean deviation of y equal to this modulus of b into mean deviation of x. This is minus 4 by 3. It becomes 4 by 3 into 5.40, and it becomes 7.20 is the mean deviation of y value. For this question, very important for this examination point of view also, MCQ point of view also. Suppose x and y are related, 4x plus 3y equal to 11. Now we have to find out the mean deviation of y when mean deviation of x is given. Simply find out express the equation y in terms of x. We have to express the y in terms of x. Y is a function of x, plus simply we have to express. After that, simply find out the value of b coefficient. This we have to take the value of b coefficient only positive value, absolute value, then multiply by given median of x, and then the value of mean deviation from x we can find. This is very important for the examination point of view. With this, I conclude the topic the range and mean deviation, and we have been discussed about the range and mean deviation. Hello students, thank you for patiently watching this lecture. Now in this part 1 we have been discussed measures of dispersion in this range and dispersion, range and measures of mean deviation only.